Hi everybody. Last time we were together, we were talking about matrices, and I told you that if we had an ice day, and we did, go out and check YouTube. Well, you guys convinced me that this is what I needed to do, so here we are. Now, what I want you to do before we get together at our next class is, this is based on our Omniquest, Capitalism at the Crossroads. And what I want you to do is to come up with a small summary statement of something that this book means to you. You want it to be small. But what we're going to do is use matrices and have an example of how it's used in cryptography. Now, with cryptography, what you're doing is taking letters and turning them into numbers and then encoding it. So the first thing that you're going to want to do, and by the way, there is a page out on Blackboard that gives this to you step by step. But I want you to understand, you are going to take whatever it is that you decide Omniquest means, and you're going to code it using the following: A equals 1, B equals 2, C equals 3, D equals 4, etc., down to Z is 26, and if you have a blank, that's a 0. Now, I was taking a look at it, and just a statement that came to mind for me was, sustainable goods. It talks about sustainability, sustainable communities, and how that can be used to perpetuate new jobs in the future. Well, if you use this particular coding scheme, here's how it codes. S is a 19, U is a 21, S is 19 again, P is 20, A is 1, I is 9, N is 14, A is 1, B is 2, L, I think is a 12. E is 5, then we have a blank, and then we have 7, 15, 15, 4, and 19. So we've taken our statement and we now have it coded. The next thing that I want you to do is to turn it into a 2 by n matrix. Now this n is going to vary depending on how long your statement is. And as you can see, if you have a long statement, you've got a lot of coding to do. Now we're going to take this statement and we're going to put it into the matrix by going down, down, down. So this 19 will be our A11, 21 will be our A21. Then we come back up to the next column, and then the next column. So it's going to be an up-down kind of pattern that we're doing. Okay, and so we're going to get to the end of our column. And I don't have enough of an ending here, so it's a blank, so I'm going to put in a 0. This is my matrix. This is what I'm going to call my coded matrix. Now, you have another task to do, and that's come up with an encoding matrix. And this encoding matrix that you're going to use is going to be a 2 by 2 matrix, and it can be anything except all the same numbers or all like 1, 2, 1, 1, something like that. For me, really the matrix 1, 2, 3, 4 seems to be a pretty good one. You can get as creative as you want to, but what you're going to do is to take this encoding matrix and you're going to multiply it times the coded matrix. So encoding times coded is going to give you your result. And we're going to call that result the coded message. Now what you need to have ready for class on Monday, and I don't care how late your Super Bowl party is, for class on Monday, you need to have your message, you need to have it coded like this, and you need to have it in a 2x(n) matrix form, and you need to have an encoding matrix. This matrix needs to have all positive numbers. You can have fractions if you want to, but I would suggest making it as simple as possible. Once you have that, in class, we're going to talk about how do you multiply these things together, and then how are you going to decode this? Because there's two parts to this assignment. You're going to have to give me the coded message. I'm going to send that to one of your colleagues in your class, and they're going to have to decode it. So it's going to be a little bit of a fun activity with cryptography, and it's going to teach you a lot about matrices, how to multiply, and what an inverse matrix will do. I can't wait to do this. We'll see you in class on Monday. Have a great rest of the weekend. If you have any questions, email me.